Okay, so this is the video lesson for Honors Math 3, Unit 9, and this is actually titled Objective 5 Notes in the notes packet that we handed out already, but it is actually for the Objective 6 assignment. So the 5 and 6 notes and assignment don't align by their name, but they do align by their title. So make sure that you pay attention that although this is Objective 5 Notes, it is specifically for the Objective 6 assignments. So one of the things that we need to make sure that we know well is our quadrant 1 unit circle. So quadrant 1 unit circle, so hopefully you know that. So we know that this is our 30 degree or pi over 6, right? So this is pi over 6. And then that ordered pair is root 3 over 2 and 1/2. And so that's our cosine value and our sine value at pi over 6. And then this next one here is pi over 4, and that ordered pair is root 2 over 2 and root 2 over 2. So our cosine value and our sine value. And then this right here is our pi over 3, so or 60 degree, and that is our ordered pair 1/2 root 3 over 2. So we do need to know our unit circle. And then, of course, this is 0 radians and pi over 2. And quadrant 1 is really the only one that we need to know because we'll use reference angles to figure out everything else. Okay? All right, so because of our modified learning, we have adjusted, so Mrs. Certain and I have adjusted what are key topics that we really need to know well based upon your next year's class, so AP Calculus, whether it's AB or BC. And so for question number 1, so this particular topic, so we've covered, something similar to this, so we did not deem this essential, so we are not going to be doing any questions like question number 1, okay? So we will not be assigning anything or assessing you on any of those, okay? All right, so let's start with question number 2. So we're jumping to number 2. So first, in general, like what we always want to make sure we do is we are reading the directions carefully. So we know, are we solving in degrees? Are we solving in radians, right? Degrees or radians. So here we're solving for theta. So theta is between 0 and 2 pi. So that means we want to be in radians. So we will always answer in radians. Okay, so the very first thing we want to do is we want to isolate that trig ratio. So what we mean by that is you're going to have some sort of trig ratio equal to a number value, right? So that would be our first step, is to isolate and solve. Let me zoom in just a little bit here. So the first thing we want to do is get cosine theta by itself. So that's going to be our first step. So we want to get cosine of 2 theta by itself. So I'm going to move the 3 and the 2 root 3 to the other side. So I'm going to add 3 over. And then from there, I want to divide by 2 root 3. So I'm going to divide both sides by 2 root 3. So when I get to this point, I can see that this is certainly not a ratio on the unit circle, and I have a radical in the denominator, which is not how we have any of those set up. So it's not that we have to rationalize, but we want to rationalize so we can see what we're working with here. So then I'm going to multiply the numerator and the denominator by root 3. And so when I simplify that, so I'm just going to do that kind of off to the side here. So I would have 3 root 3. And then when I multiply these together, that gives me the square root of 9 or 3, right? So 3 root 3, and then root 3 times itself would just be 3. So those 3's will cancel. So then what I have now is cosine of 2 theta is equal to the square root of 3 over 2. Okay, so that's my first step, is just isolate the trig ratio. So step 1 is done. And then for step 2, we want to determine the reference angle. So I am a big fan of just finding that reference angle so I can kind of learn how to navigate the unit circle. So I am just looking for theta prime right now. So this is not like a final solution. I'm just trying to find theta prime. So when I look at this right here, so I know that theta prime, which is not my final answer, right? So I'm just looking for where does cosine equal the square root of 3 over 2? So where does cosine equal the square root of 3 over 2? So we either have that memorized or we have the hand trick or however we need to, but we need to know that particular value. So if I were to look on the unit circle, where is the x value equal to the square root of 3 over 2? And that would be at pi over 6. Okay? So then I know my reference angle is pi over 6. So that is not my final answer, right? That is just my reference angle. So, but keep in mind that we are not solving for just theta, we are looking for 2 theta. So we're looking for 2 theta. So if I am looking for where theta prime is pi over 6, and I know that this is a positive ratio, right? So a positive ratio. So then that means that cosine is positive to the right because it's my x value, right? So that means I should have an answer in quadrant 1 and I should have an answer in quadrant 4, right? So I'm looking for an answer in 1 and in 4. So I certainly know that in quadrant 1 it's just going to be pi over 6, right? Pi over 6. And then my second answer is going to rotate all the way around from 0 and it's going to stop right before I get to 2 pi. So at 2 pi, that would be 12 pi over 6, right? And that's just giving me a common denominator. So I know 2 pi is just 12 pi over 6, right? Because 12 divided by 6. And so then I fall short of 12 pi over 6, so I don't make it all the way there. I stop right before I get to that. And so my second value for 2 theta would be 11 pi over 6, okay? So once again, I know that the reference angle is pi over 6, and then cosine has a positive ratio in 1 and 4. So quadrant 1 is just the reference angle, pi over 6, and then quadrant 4 is going to be 11 pi over 6. So now that is step 4, right? That is my rotated angle. So what have I done so far? Found my reference angle. Theta prime, I found the quadrants where it's positive or negative based upon the ratio. So the ratio is positive, so I looked for where it was positive. So then what I just found was what I call the rotated angles from b theta. So in this case, b was 2. So now what I need to do, so step 5, so this is new to us, is I want to add 2 pi to each angle and repeat as needed to create b pairs of rotated angles. So step 5, what does that mean? So when I have a 2 theta here, that means I'm rotating around the circle twice as fast, right? We're speeding up, we're going around twice as fast. So I have to rotate through the circle, unit circle, twice. So I need to rotate through twice. So this is just rotation 1, right? So this is just my first rotation. So I need to find my second rotation. So that means I need a whole nother set of answers here for the second time I rotate through. And I do that by adding 2 pi. So that's our coterminal angles, right? Our coterminal angles. So my first time through for pi over 6. So if I go 12 pi over 6 plus another pi over 6, that would put me at 13 pi over 6. And then for my other angle, so 11 pi over 6, so if I go through, I went 11 pi over 6, right? So 12 pi over 6 plus another 11. So that would put me at 23 pi over 6, okay? So what did I do here? I found my first 2 rotated angles, and then because that was a 2 theta, I need to rotate through the circle twice. So my second rotation, all I did was add 2 pi, which is the same as 12 pi over 6 to both of these. So 1 pi over 6 plus 12 pi over 6 gave me that. And 11 pi over 6 plus 12 pi over 6 gave me that. Okay, so last step here, so step 6, now I have to find theta by dividing by 2, right? Because I want theta by itself, because that's really what I'm solving for. So I'm going to divide everything by 2. And I know dividing by 2 is the same as multiplying by 1/2. So then I'm just going to multiply everything by 1/2. So this will be pi times 1 over 6 times 2. 11 pi times 1/2, so that would be 11 pi over 12. 13 pi over 6 times 1/2. And then finally 23 pi over 6 times 1/2. So that would be my final answers. And if I look, every single one of these is under 2 pi, right? So 24 pi over 12 would be 2 pi. So these would be my 4 answers. Okay, 4 answers. So what if this had been a 3 theta? So if it had been a 3 theta, I should have 3 pairs, a first rotation, a second rotation, a third rotation. Okay, and that would be that. Okay, so let's take a look at question number 3. So let me jump to that one. Okay, so same direction. So question number 3. So we want to isolate the trig ratio. So then I am going to add 1. And then divide by 3. Whoops, that will stay cotangent, not cosine. And then I'm going to square root both sides. So normally this would be absolute value, right? So if it's absolute value, then that's just going to make this a positive or a negative, right? So then I want to square root 1, which is just 1, and then the square root of 3 is just the square root of 3. So now for cotangent, I'm looking to see where does cotangent equal 1 over root 3. So if I look at my unit circle, so cotangent is adjacent over opposite, right? So adjacent over opposite. So adjacent is my x value, so x over y. So if I look at pi over 6, x over y would be root 3 over 1, so it's not pi over 6. At pi over 4, it would be root 2 divided by itself, so that's just 1, so that can't be that. And then for pi over 3, it would be 1 over root 3. So that would be what we're looking for. So cotangent would be pi over 3, right? So pi over 3. So I have that theta prime, my reference angle, is pi over 3. And I know that cotangent is either positive or negative in any of the quadrants, right? So that means I'm going to have an answer in quadrant 1, 2, 3, and 4. Right? So because it's plus or minus, I need to look in all 4 quadrants. And so then I know that to get a common denominator, that's just 3 pi over 3. And so my quadrant 1, so again, this is for 2 theta though, right? So this is still 2 theta. So 2 theta. So quadrant 1 is just my reference angle. Then when I rotate to quadrant 2, I don't make it to 3 pi over 3, so it's going to fall 1 short of that, so that would be 2 pi over 3. And then when I rotate to quadrant 3, I'm going past 3 pi over 3. By 1, right? And then 3 pi over 3 doubled, so 2 pi would be 6 pi over 3. So let me write that over here. So for the 6 pi over 3, so to get into quadrant 4, I stop before I get to 6 pi over 3. So the number right before that would be 5 pi over 3. So that's just my first rotation, right? So I have 4 answers in my first rotation because of that, plus or minus. So I have to have a second rotation because that's a 2 theta, and if it had been a 3 theta, I would have 3 rotations, right? So 2 is already bad enough, so thankfully it's not 3. So how do I find my second rotation? I need to add 2 pi, which is the same as 6 pi over 3, to each one of these. So I'm going to do 1 pi over 3 plus 6 pi over 3. 2 pi over 3 plus 6 pi over 3. 4 pi over 3 plus 6 pi over 3. And then finally 5 pi over 3 plus 6 pi over 3. So that is my second rotation. So I'm just going to start abbreviating that, second R. And so now in order for me to solve for theta, I'm going to multiply both sides by 1/2. So I'm going to take 1/2, so I'm going to multiply this by 1/2, so that would give me just theta. And then when I multiply by 1/2 to each of these, then that's really just going to double the denominator, right? So the numerator is multiplied by 1, the denominator by 2. So I'm multiplying by 1/2. So each of those denominators gets doubled. And then any of these that reduce, I should reduce, right? So in this particular one, 2 pi over 6 reduces to pi over 3. 4 pi over 6 to 2 pi over 3. And then 8 pi over 6 to 4 pi over 3. 10 pi over 6 to 5 pi over 3, and then of course 11 pi over 6. So then I have 8 answers because I had a square root that rotated twice. There we go. Okay. All right, so let's take a look at question number 4. So number 4 here. So for this one here, so we need to isolate the trig ratio. So I don't just have one trig ratio, right? I don't have like just cosine to get by itself or just the sine 3 theta get by itself. I have like combination of the two. So that means I want to look at trying to factor. So if I look here, I have a GCF. So I have two terms and they both have a cosine common, right? So I have two terms. This is my first term separated by my second term with addition. So they both have a cosine common, so that's what I want to factor out. So I'm going to factor out a cosine of theta from both of these. So when I divide cosine out of here, I'm left with 2 sine 3 theta. And when I divide a cosine out of here, I'm left with 1. And I can factor because it is equal to 0. So if this was equal to something other than 0, I would have to add or subtract that term over before I try to factor, right? So always equal to 0. To be able to use the zero product property. So then once I have that factored, I can separate my factors and solve independently. So I have cosine theta equal to 0. And so I'm just looking where is theta equal to 0. So this is a quadrantal, right? So where cosine is equal to 0 is a quadrantal. So again, I would be looking at my unit circle to do that, right? So I'm looking for where my x terms are 0, so my quadrantals. So my x's are 0 here and here, so at these two spots on the y-axis quadrantal. So that would be at pi over 2 and 3 pi over 2. So then that one's done, right? So there's 2 answers so far. And so then I have this factor that I want to solve, and I can solve it separately because I'm using the zero product property, so equal to 0. So for me to solve that, I want to isolate the trig function just like I have done before already. So I want to isolate, so I'm going to go ahead and subtract 1. And then divide by 2. So then I'm looking for my reference angle. So remember, for my reference angle, this is not my final answer, right? So where does sine equal 1/2? So first focus on where does it equal 1/2. And then that is at pi over 6. And then where is sine negative? So I'm going to just do that up here. So I know sine is my y value, so it is negative when I go down. So in quadrant 3 and in 4. So quadrant 3 and 4. So then I want to be in terms of 6, so this would be 6 pi over 6 here, and then 12 pi over 6. So then my rotated angles are from 0, and I know I'm going to go pi over 6 away to be in quadrant 3, so that would be 3 theta, because that's 3 theta. So that's bigger than 6 pi over 6, so that would put me at 7 pi over 6. And then for my quadrant 4, so if I rotate, I stop before I get to 12 pi over 6, so that would be 11 pi over 6. So then I know I need to add 2 pi, and I have to do it 3 times, 3 rotations, because this is a 3 theta. So I have to have 3 rotations, so I want to know what is 2 pi, so I can add that pretty easily. So 2 pi in terms of 6, remember, is 12 pi over 6. So I have that up here. I'm just writing it down here just so I have something to look at. So my first rotation, so r dot, my rotation abbreviation. So now I'm going to add 12 pi over 6 to both of these. So to here and to here. So that's just the second rotation, but I need one more, right? So I need one more rotation. I need a third rotation because that is a 3 theta. So then I'm going to add 12 pi over 6 to my second rotation. So 12 pi added to this one. So that would be 31 pi over 6. And 12 pi over 6 to this one. That would give me 35 pi over 6. And so that would be my third rotation. And then my final answer is I'm going to divide everything by 3, which is the same thing as multiplying by 1/3, right? So I'm going to multiply by 1/3 and 1/3. So all the numerators are being multiplied by 1, all the denominators by 3. So the numerators are going to stay the same, and the denominators are all going to turn into 6 times 3, which is 18. And I just realized I have these two answers down here as well. Let me just kind of write them separate. But all of those would be my answers, right? I have these 6 plus those 2. So all of those would end up being my answers. Okay, so question number 5. Let me get some scratch paper. Like, took over some of my workspace, so I'm going to steal some scratch paper here. Okay, so let's take a look at question number 5. So for question number 5, so for this one right here, so I'm kind of running into that same kind of predicament where I don't have a single trig function, right? I don't just have sine only. I have a sine squared with a sine theta, so that means that I'm going to have to factor, right? So for my factors, so I want to think of this as kind of like 3x squared plus 7x plus 4, right? That's the way I kind of need to visualize that. So this is like 3x squared plus 7x plus 4, and like that's what I'm trying to factor, right? Isn't that what I'm working with? So that's kind of the way I need to be thinking about that. So I want to think of my factors for 3x squared. The only possibility is 3x and x. And my factors are either 1 and 4, 1 times 4, or 2 times 2. But I'm trying to figure out what is that combination that will give me that 7x. So I know it could be 3x and x. That's my only possibility. So it could either be 1 and 4 or 2 and 2, but somehow I have to get that 7x. So I'm going to start with the one that I know doesn't work. So I know it's not 2 and 2, but I want to go ahead and show you why it's not 2 and 2. Because that would be when I do the outer inner, I would get 2x here, and when I do outer inner here, I would get 3x times 2, but that adds up to 8x. And that's not what I'm trying to get, right? I'm trying to get a 7x. I'm trying to get that guy right there in the middle, okay? So I know it's not 2 and 2, so that must mean it's 4 and 1, right? So 4 and 1. So if I have 3x and x, I need to figure out where does that 4 go, where does that 1 go? So if I put the 4 here, then I would create a 12x, right? And that's way too big, so I'll bet it goes there. And so now if I were to check that, it would be 4x when I multiply, 3x times 1 when I multiply, and then when I add, I get 7x, which is what I was shooting for, right? So that is my factoring, right? That's the factoring I want to use. And so let me go ahead and just kind of flip this over, and we'll start from that, right? But I don't have x squared, I have sine squared, so that's when that's my unknown. So my factors, so I said were 3 sine 2 theta, sine 2 theta. Whoops, that's a 0 there. Let's scoot that over just a little bit. And 4 and 1, right? So plus 4 plus 1. So I could check that, right, if I wasn't sure. So if I multiply 3 sine 2 theta times itself, I get 3 sine squared 2 theta. And then if I do my outer inner, I get 4 sine 2 theta plus 3 sine 2 theta, which gives me the 7. And then 4 times 1 gives me that 4. Okay. And then from there, I want to go ahead and set each factor equal to 0, and I can do that because it is equal to 0. So now I'm going to use 0 product property. So set my first factor equal to 0, and then my second factor equal to 0. And then from there solve, so I'm going to subtract 4. And divide by 3. So negative 4/3 does not sound familiar, right? Certainly not on the unit circle. So 1/2, root 3 over 2, root 2 over 2, so on and so forth. So that kind of is a problem, right? So, but more importantly, I know that the sine ratio is opposite over hypotenuse. And is it possible for the opposite side to be bigger than the hypotenuse? And that is not, right? Because the hypotenuse should always be larger. And so I also know that it's no solution because cosine cannot be beyond 1 or -1, right? So the highest it goes is 1, the lowest is -1. So whichever way I want to think about it, I know this will be a no solution over here. So woohoo! I only have to actually solve one of the factors. So excellent news. So let's go ahead and solve this one here. So I'm going to subtract 1 from both sides. And then I know this is a quadrantal, so I'm looking for where sine is equal to -1. So sine is my y value, so where is y equal to -1? And that's only one place right here at 3 pi over 2. So that's always fabulous when I get a quadrantal. So then I know that 2 theta is just 3 pi over 2. That's the only possibility, right? Usually we would get 2, but because it's -1, there's only one place that happens. That is at 3 pi over 2. But I still have to have 2 rotations, right? So this is only my first rotation. So then I need one more, right? I need that second rotation. And I find that second rotation by adding 2 pi, right? So I want to add 2 pi. So just kind of off to the side right here. So I know that 2 pi is the same as 4 pi divided by 2. So again, I'm just trying to get that common denominator, right? So then I want to add 4 pi divided by 2. So that would give me 7 pi divided by 2. And then my final step is to solve for theta, and I'm going to do that by dividing by 2 or multiplying by 1/2. So when I multiply by 1/2, I would get 3 pi over 4, multiply by 1/2, 7 pi over 4. And so I only get 2 answers out of that whole problem. And one more here, so let's take a look at question number 6. So question number 6. Okay, so for this one right here, so again, we want to solve by factoring, and I know I need to solve by factoring because I have no way to isolate, right? I can't get sine by itself, can't get cosine by itself, so I have to solve by factoring. Well, this is even a bigger problem because I have mixed trig ratios and I don't have a GCF, right? It's not like I can pull a cosine out of everything like I did in number 4, right? So I was able to do GCF here because they both had a cosine. And then for number 5, I was able to just straight factor because they were both in terms of sine, right? Sine squared and sine. So I have to do something else, right? So I recognize that I have 2 different trig functions. One is squared and one is not. So the tip here is to convert one of these to sine, or like cosine to sine or sine to cosine. Like I have to be able to use that. And the only identity I have, right, so the only identity I have is the Pythagorean identity, thus far, that relates sine and cosine, right? That's the only one I have so far. So I have to use this identity to help me do the substitution. So I'm not trying to do a proof, right? So I'm not trying to prove these things. So I can use any modified version of this because I'm not doing a proof. So I don't have just sine in here, so that means that cosine squared is a 1 I'm trying to substitute. So if I use this identity here, I know that cosine squared is equivalent to 1 minus sine squared x, okay? So this is the substitution I want to use. So again, I'm not trying to do a proof, I'm just trying to do a substitution to help me solve this equation, right? So I'm going to take cosine squared here, and I'm going to replace it with 1 minus sine squared. So that's going to be my substitution. So I have a 2 in front, And then I'm going to replace cosine squared with 1 minus sine squared. And then plus sine x minus 1 is still in the equation. So again, all I've done is replace cosine squared with 1 minus sine squared using the Pythagorean identity. So now I want to simplify this and put it into the same form as I had for number 5. So into your normal trinomial quadratic. So I'm going to go ahead and distribute the 2. How about distribute the 2? Let me try that again one more time. So 2 times 1 is 2, and then distribute the 2 right here. And then just copy down the rest, right? Okay, so then once I get to here, I'm going to go ahead and combine like terms. So I can go ahead and combine positive 2 with negative 1. And 2 minus 1 is just 1. So I am not a big fan of trying to factor when I have a negative leading coefficient. Totally doable, and I know some of you do that. But I'm just going to multiply both sides of the equation by negative 1, so I don't have to do that. So I'm just going to multiply everything by negative 1, and that's just so my leading coefficient becomes positive. So that will turn this into positive 2 sine squared x. That will turn into negative sine x. And then positive 1 into negative 1, and then 0 times negative 1 is still 0. So then once I get to here, now I'm going to solve it just like I did question number 5. And I just realized the directions said to solve for theta, and these are x's, but just go with it, people. So we're going to pretend those x's are thetas, and those directions still apply. So I'm just going to look to factor this, so I'm going to just kind of group it out. So I know the only way to get 2 sine squared when I multiply is 2 sine x and sine x, and the only way to get a 1 is 1 times 1. But I need this to be negative 1, so I have to like decide, you know, which one's going to be positive, which one's going to be negative. And I want my negative to be the larger one because my middle term is negative. So if I were to check it, 2 sine times itself gives me 2 sine squared. 2 times negative 1, so that's negative 2 sine x plus 1 sine x, which is negative sine x, and then 1 times negative 1 is negative 1. So now I can use zero product property because I have factors equal to 0. So then I can solve these individually, right? So over here I have 2 sine x plus 1 is equal to 0, and sine of x minus 1 equal to 0. So I'm going to go ahead and subtract 1 from both sides, and then divide by 2. And so my theta prime is going to be pi over 6, right? That's my reference angle. So where is sine equal to 1/2? And that's at 30 degrees, or pi over 6. And then I know that sine is negative where it is below the x-axis. So that's here and here, because sine is my y value. And so this would be 6 pi over 6, 12 pi over 6. And I'm going to run out of room here, so let me just kind of scoot that over. So then my rotated angles for this one are going to be from 0 past 6 pi over 6, so that would put it at 7 pi over 6. And then for quadrant 4, right before I get to 12 pi over 6, which would be 11 pi over 6. So there's 2 of my answers so far. And then finally for this one right here, so I'm going to add 1 over to the other side. And then that's a quadrantal. And so I'm looking for where sine is equal to 1, right? So where is the y value equal to 1? And that's up at pi over 2. And 3 pi over 2 would be negative 1, so that would be the only one. And I just realized I'm kind of mixing variables. So pretend these are x's and x prime. There we go. And that is it for objective 5 notes, which is for objective 6 homework.